Alright, so we're going to review the Continental Drift theory that was presented in your class. I'm just going over the essential questions. These are things we will probably be test over. Who is Alfred Wegener? What is the historical evidence that supports the Continental Drift theory? What causes the movement of the continents? This is something you did in class. Just refer to your notes. So Alfred Wegener proposed the Continental Drift theory, the idea that Earth's continents moved apart from a single large continent called Pangaea. Despite a large body of compelling fossil and rock evidence, his theory was rejected by most scientists. He could not explain how the continents moved. It was only in the 1960s that the Continental Drift theory finally became accepted and became part of the theory of plate tectonics. So just remember, Pangaea was the supercontinent. Began to break apart about 175 million years ago. There were probably other supercontinents before Pangaea. The Earth's continents have been continually breaking apart and coming together. It's really important to remember. So fossil evidence is one of the main things that leads to continental drift theory. Fossils of the same species were found on separate continents and nowhere else. These plants and animals would have had to evolve independently or swim the distances, which is impossible, considering the species. Fossils found didn't fit the climate. For example, palm tree leaf fossils were found in Alaska. So let's take a second and look at this area here. So if you found a fossil that was in this area and this area in Africa, and they were the same fossil, for example, fossil remains of this creature here, you just go on an expedition, you find the same fossils. The thing that makes the most sense really is not that they swam across, but that they used to be a part of the same environment. Continental fit. This is the puzzle piece idea. It's another piece of evidence that continents were once joined. Glacial evidence. So it's our third main piece of evidence. So as a review, we have fossil evidence, glacial evidence, and the puzzle piece evidence. Glacial deposits formed 300 million years ago are found in Antarctica, Africa, South America, India, and Australia. Striations, scratches on rocks, show the ice flowing from the glaciers came from a single point. Evidence of glaciers is found in warm climates today. So that's important because obviously we would not see glaciers in warm climates because they would melt too fast. So they had to have been in a very cold environment at some point in the past. Like Australia, for example, would have been in a colder environment as a part of Pangaea. The Appalachian Mountain matched well with those on the British Isle as well as other places. So this is our fourth main piece of evidence. So we have, as a reminder, fossils, puzzle piece, glacial deposits, those striations, those lines, and now landforms and rock layers that seem to have at one point been a part of the same mountain system. Similar types of rocks and similar ages of rocks were found on these three continents and other places. The coal fields in North America and Europe match up. So just For your review, can you identify Alfred Wegener and his contributions to the Continental Drift theory? What I get from that is, if we did not talk about it in these slides, it didn't have anything to do with Alfred Wegener. So I'd like to remind you of what we talked about in our labs when we were doing the Organize It station. A lot of people got confused what Alfred Wegener talked about and what he didn't, I noticed. So there were puzzle pieces. Continents fit together like puzzle pieces. We had fossil evidence, glacial striations, or those lines of scratch marks, and we had mountain ranges and rock types match up across the sea. And the example of that was the Appalachian Mountains matches to the British Isles. So just keep those in mind. Thank you very much. Good luck on your test.